So I'm going to study the fundamental x86 patterns, and I'm thinking about just creating Anki cards and then using Godbolt to probably gonna use ChatGPT to create some examples. I already have some, and I managed to also I realized that it's better to separate the examples into their specific executables, so I can go over them with x64 DBG. And also, so basically this is the command you have to use if you're using MSVC. So if you're using CMake with Windows, this allows you to set special flags for the compiler. And this you can put some extra conditions here to check, to make CMake check whether or not you are on Windows or Linux. But I'm just doing the simplest thing as possible because I don't care that much, just to a very small thing to learn how to not to learn, but to improve the fundamental patterns on assembly. Because I already know a bunch of stuff, but I'm trying to reinforce the fundamental. I created this list here, which is basically what I'm gonna try to follow. So the idea that I have is to create examples from ChatGPT based on these patterns here, then put them on Godbolts, and then from the comparison create some Anki cards that are gonna have, but I'm gonna try to simplify as much as possible so I get only to the parts that matters. So the Anki cards, and unfortunately I couldn't find an easy way to type the answer if you're typing code, because the code has to be formatted. So I think it's just fine to put the format on the front and then put the answer right away without typing on the back. So the front's gonna be the C++ code or the C code, and the back's gonna be the assembly code. But if you are on Windows and if you're using CMake and you're gonna do like CMake gets very annoying when you have extra packages and things you have to do. Like there is no standard version like npm or pip. npm from JavaScript or from Node.js and pip from Python. So the closest thing you have is Conan, I think, and you can also use scones, which is a Python tool that Godot uses to build everything. But I think in most situations, if you're doing a project from scratch, you're gonna have to use CMake, and then either you're gonna have to use this add subdirectory, which is gonna just basically include the whatever folder you put there that has a CMake file. So it's gonna link that to the build, and then you can use some special commands as well to create libraries and link that to the target, which is very annoying. But for this simple project here, you can use the set to set the flags, and this is basically telling MSVC compiler to generate assembly code, and then here you can put the path of where you want the assembly files should be, the final assembly files. If you don't put anything, you're just gonna put on the build folder. And I got this command here from ChatGPT, but it seems to be working. So it's generating the assembly from the C++ code there. And I think this is cool because you can look like it's different because of the extra information that you have. So the assembly that gets generated here is different than the one that gets generated from Godbolt, which is different from the one that gets generated from x64 DBG. I think just because of the extra information of the symbols and the organization of the compiler and how it's gonna, because on the different environments, the assembly file is gonna be used to create the final executable by implementing the linker. So the linker is gonna connect all the files, the code from the assembly files. And here there is, on these files, there is a lot of code I think that is related only to the linker and to MSVC. And on the other ones, I think it's more simple. So I think this one is useful to try to understand like, or try to clarify what does the include, like the import system on assembly, how does it work? And the other ones are more useful to go direct to the point. So obviously the x64 DBG is going to be useful for understand what happens on the runtime actually when you're running the code, and Godbot is going to be useful to see the static analysis, to just how the actual code gets translated into assembly by whatever compiler you select there. In this case, I'm using MSVC. And here it seems like it is, maybe I chose the wrong one. No, it is x86, yeah. It's confusing because of 64 and 86. Yeah, but it is 86, so it is the correct one there. So let me put some music for myself. And I asked GPT how to. So basically, if you use this tags here, it's gonna format whatever you put inside as code. But it didn't give me an answer on how to structure the format of the answer, like for you to type the answer in the same format. And it's just annoying, so I don't think it's worth it. So I think this way is probably better. But I was gonna say something else. So I think I'm just gonna let me think about. So the first thing that I was doing before, just now before I started streaming, is to create simple. So I created two different decks there. One, and this is the parts. So the way that I'm thinking about structuring right now is that the fundamental patterns is gonna have this, like the C code on the front and the assembly on the back. And the flags and nuances are gonna be like small things that are useful to remember, but they don't fit on the like the code. So for I think the main example that I'm thinking about now is the control register tree, which seems to be the register that is used to translate the virtual addresses from the process into the physical addresses on the hardware. So that register is going to contain the bits that are going to translate the information, and from the virtual address on the process is going to translate into a virtual page that the default I think is for 4096 megabytes I think, like one page size, and then there's some architectures that they allow you to have bigger pages, and there's some nuances about that I'm not 100% sure. But it looks like yeah, I'm pretty sure that the main organization, let's say, of the flow of memory between different hardware components is going to be done through bit field registers. And a bit field is just a register that is going to, instead of the register representing a number, each field of the register, each square, is going to represent a control logic that the CPU is going to use, because on the CPU, everything is going to be connected to these circuits, and the control logic is basically the impulse that I think most of the time is probably going to go on a decoder or a multiplexer. And it's kind of the difference between decoder and multiplexer is kind of confusing because it seems like they are kind of the same thing, but the multiplexer I think is more advanced version of a decoder. So what a decoder basically does is translates an amount of inputs into another amount, which is a multiple of 2. So let's say you have 2 inputs, it transforms into 4 outputs, and it allows you basically to select what's going to happen based on the 2 inputs. So that's usually the reason why it is used on the control logic, because you're going to have the 2 inputs that come from the control of the CPU. They're going to dictate what's going to happen on the other parts of the components. And the multiplexer is going to be almost the same thing, but you have a selectors. So you have inputs, then you have selectors, and then you have outputs. And it works basically as the first function, the hard-coded function on the hardware, that is going to allow you to do like operations. I think that I don't remember really well, but I think probably branch instructions they use multiplexer and some other. The ALU is gonna be before the ALU probably. But on these connections, they are gonna be connected to these registers that are bit field registers. So I think on this one, I was thinking about, I got this from a book that I was reading, and I was initially I was thinking about, so there's three main types of cards that I like doing. One is you put the answer on the front, and then on the back you just put the response. The other one is basically the same, but you have to type the answer. And the third one is image occlusion, which you put the image and then you edit the image, you put some squares on the image, and then it allows you to type one of the squares on the image. But the problem is that there's only 2 options there. And I didn't like that, so now I'm thinking more about translating this. Probably that's the first thing I'm gonna do. Not sure if I can do like this. Uh, Sometimes it bugs. So I already added a first one. So basically that's like you have the front's gonna be whatever shows up on the front, and the back is on the back, obviously. So I think the first one I did, let me see the first. Don't remember if I can click. The easiest way is just see here. So I did like this, GZ jumps if, and then I put C F equals 1. Because I want to memorize the relationship between the jumps and the flags that have to be set for them to work. Because this is one of the confusing parts that I found as I was stepping over the x64 DBG for the Flare-On challenge there is a lot of jumps where I think it's mainly the jump equal or jump not equal, that they are not equal, and that's the part that is confusing. The jump not equal jumps if the ZF is 0, like it says here, and the jump equal jumps if the ZF is 1. So it's more like jump if not 0. And the reason why it is like this is because, as far as I understand, the equality is usually going to be done by subtracting one number from the other, and that makes sense. Obviously, if both numbers are positive, but then you can use different instructions depending on whether or not numbers are positive or negative. Which is another thing that I'm going to probably put here. I'm going to have to study this part, but probably I'm going to look into the examples to see how this part works with negative numbers. But it's basically the same idea, like you subtract one number from the other, and if it is 0, then it means that they are equal. So that's why they use the 0 flag. It's probably more effective to do it this way. But it is kind of confusing when you're stepping over, because some situations they're going to use the test instruction against a register. So you test a register against itself, and what the test is just an AND, bitwise AND between the two registers. And when you do that, you're basically checking to see if the value on the register is 0. But it is kind of confusing. So that's the reason why I'm thinking about doing this one here. So I'm going to write down probably GE jumps if, and then I'm going to do like all these values probably. It's probably better to do one column at a time. Maybe not, actually. I'm gonna use the first one as an example, and then just put this other one on the other monitor. And I'm going to just write there. So this one, and you have the comparison. The comparison is another one that is very confusing. So honestly, for those ones, I'm gonna have to ask ChatGPT. The stack frame examples I already got from ChatGPT. And I'm just gonna put there. But maybe, I think it probably is better to do this off stream. I think I'm just gonna look into the examples now. And then later, so I'm gonna look into the examples, and if I have time later, I'm going to translate them into Anki. So I'm gonna ask ChatGPT there. Let me start with the functions. I think there's so many things to look into that it's kind of hard to think about what things are most interesting to look at first. So obviously, basically, here you type the code in C or C++. I think you can do more languages here. So you can type on any language, and it's just gonna show you the assembly. And this is very interesting. I didn't realize that you can do Python and JavaScript here as well. And the LLVM. That's very interesting, actually. Because the higher the language, the more confusing it is. And this is another thing that I was thinking about, because obviously you're gonna have layers of abstractions. So the way that I'm thinking about programming now is like a lot more clear on my mind on how everything works. Like all that the evolution of programming is just people building abstraction based on the fundamental patterns, which is just a Turing complete. And Turing complete just means that like you have a computer that has a line, and is walking through the line, and then each line you can make a decision on either to do one thing or the other thing. So basically branching. And just with the execution and the line, you can create all the other concepts, because the other concepts are just abstractions built on top of this. And the reason why I think that it works this way is because information is a tree. So that's why information is directly correlated with entropy, because in order to have an unlikely event, you need more information to encode an unlikely event, because it's an information of is a tree of decisions, and the walk through the tree determines the probability of something happening. So the bigger the tree, the more information you have, and paradoxically, the more entropy you have, because the least likely events you have. So it's like two sides of the same coin. And I think computation is just capturing that. So it's like the abstract relationship of space-time. And so the example that I was thinking about on C++ that makes it hard to think about is that if you have a simple comparison, you can do a branch on assembly. And this is probably what I'm going to start with, which is basically comparing two numbers, two integers, for example. So compare a equals 1, b equals 2, and then you compare whether or not a is greater than b, and then you do the branching that way. But the problem is on C, obviously you're going to have, maybe not C, I'm not 100% sure if you, I think even, no, in C you can't actually, because C is just functions. But actually, maybe you can overload the, yeah, now I'm not really sure. I'm gonna ask this ChatGPT. But I think probably you can't overload. So I'm gonna start a new chat. Yeah, in C you cannot, because you only have functions, you don't have classes. But on C++, for example, you can do this where you are changing the behavior of what's going to happen when you have the equal sign. Because, like I said, the language is just an abstraction that you build on top of this fundamental pattern, which is just a branch. So you're going to use sequences of branches and calculations to encode routine, which is a function. And then from that, you are able to create the symbol, because it's going to be a finite state machine. So the language is a finite state machine. It takes one input, and then over a sequence of heuristics, it's going to translate that input into another input. It's going to translate into an output that is the assembly, which is the interface with the hardware, which is machine code. So the symbols of the operators, equal and multiplication, everything else like that, it's just going to be the finite state machine that is connecting with the lower level, which is the assembly. So when you're comparing two different classes on C, it's going to be a lot harder to see the representation on assembly, because you're going to have the extra embedded abstraction, which is the structure of the classes and the relationship of the memory that brings. And I think that the more complex the example becomes, the harder it becomes to understand what is going on because of that. And I think this is the double-edged sword that you have, because the higher level languages, and I think this is a property of group dynamics, because it's Occam's razor. So the reason why things converge this way is because the language is going to be a reflection of the abstract symbolic representation that the network has to maximize energy efficiency over space-time. And I think this is the property that markets capture, because you are always incentivized to maximize energy, minimize risk. So the more convenient something is, the more likely it is to capture markets, because everyone's trying to maximize energy. And because of that, you have these stride mechanisms, which is the same way that language evolves with memes. So memes is just capturing this pattern as well, where encapsulating the geometry of a network into symbols. I think that's what Jung said as well, is like archetypes. So that's basically what a language is, I think. I'm gonna close the window. So yeah, the reason why I was saying that is because of the trade-offs thing. Is that the reason why it makes sense, and I figure out why types are complicated because the types are going to be on the range between subjectivity and objectivity. So it's a convergence towards infinite potential. That is going to depend on the context, and that's basically the structure of programming languages. So it's gonna the trade-off you make is that you create a heuristic that stops you from having flexibility every time you create a new language because you're encoding complexity on the compiler. So the compiler is just a sequence of rule sets that encodes Occam's razor on a network of people, and it works as an interface of symbols that allows you to develop faster because you can compress the information. But the flip side of that is that you're going to lose the flexibility of the power you have, the lower level you go, because you have the assumptions that people made when they created a compiler. So obviously, understanding the lower level languages make a lot of sense because it allows you to understand the trade-offs that were made. But it becomes less likely to be effective to code in lower level because higher level is more, it's easier to write because you don't have, it's like less likely in the same way, it's for the same reason that it's very hard to beat the market because even though you can throw a bunch of compute to beat the market, it's very uh, unlikely that you're going to be able to beat Occam's razor from the market because the market's already capturing that dynamic on groups. So like there's going to be a bunch of people that work on the compiler and then they optimize everything. So it becomes more likely that you're not going to be able to write assembly that it's going to be more effective than the compiler produces. And the complexity comes on the types because that's what's going to change on runtime. So that's one of the things that I'm trying to clarify here. So study the fundamental patterns and then clarify how the types are built and how the relationship between the types are like on the chain of abstraction, what's going on the optimizations. It's very hard to think about. It's very complex. So here is just doing the beginning of the stack frame. So it pushes the base pointer to the stack. I think this register is going to contain the address of the base of the stack. Then is moving ESP to BP. I think when it does that, it's going to change the value of EBP. Yeah, so I think it pushes the old address to the stack, which will be like the return address. And then it updates that value with the top of the stack. But how does it know where the top of the stack is? It's saved on the register, not the stack. So I think it's just saving the return address and then it updates the base pointer to point to the top of the stack, even though it's not going to be on this stack. Then it calls the function, which is what I'm calling here. It's going to be this label here. So this basically does the same thing, pushes EBP. So EBP now is going to be ESP from previously. So it's pushing the return statement and then it's updating with ESP. And this is one of the things that is kind of confusing, which is one of the things that I'm trying to clarify by going through these examples is the relationship between the local variables and the arguments of the functions and the conventions of each one. But it looks like so I wrote down here, I'm just going to use the ECX there, which is a counter register. And it seems that these are conventions. Also from a video, or I think from the book, I saw this comment here. Shadow store is used if a function needs to save its register parameters in memory. So based on the book, it seems that like every time that you are using MSPC, it's very likely that you're going to encounter some calculation on the RSP, which is the stack pointer, to put empty values on the stack according to the 16-byte alignment that the stack has. So 8 bytes for each row on the 64-bit. And 16 is going to be 2 words, which is 16 bytes. So the reason why the MSPC creates the shadow store is in case you have a situation where the caller, which is the function that is calling another function, has to save the state of the registers, I think. Register parameters in memory. But I'm not really sure that's true or not. I just read in the book and then I wrote it down here. 32 space for 4 possible register parameters should be stored on the stack. Yeah, because each parameter would take the value of a row. That's a register. And according to stuff we've seen before as well, this seems to be the caller. The registers that the caller is going to use to save values. But I don't remember exactly what it means by this. And it looks like RCX is here. So RCX is counter register. I think we took a picture of this as well. I have a bunch of pictures now about a bunch of stuff. Yeah, so basically here. So CX is counter register, DX data. ESI and EDI are usually used for moving strings, but I think for other operations probably used as well. But the one that I've seen examples the most, I think, is the strings that use a special functional assembly that is just going to iterate over the bytes of this register, which is the source, and puts on the destination, which is this one. So it's just translating the bytes from one register to the other in one command there. I think it's usually used for strings. Okay, so here it's going to push the local variable to the stack, and then it puts. And this is interesting because it's moving to this weird thing. So why is this value? Let's see if ChatGPT can explain this. So obviously what I think is happening is that it's pushing this register here to deal with the local variable, hold the value of the local variable, so the register is basically A. This is another thing that I'm not 100% sure, but I think that's how it works. There's a compiler, like the way that the compiler works on LLVM is going to be to try to make each assignment to be unique, because that it makes it easier to do some optimizations based on the way that it creates the graphs. So there's the control flow graph, which is a graph that is created based on the program that's going to be based on the branches, which is going to allow for a bunch of optimizations you can do by traversing the graph. And it's the same with local variables because of the reordering of the instructions that you can have on the hardware. and then obviously the compilers are going to try to optimize for that. So, and this is directly correlated with the memory model. This is one of the parts that is confusing because the order of the instructions is directly correlated with the memory consistency and memory coherence on the hardware. Because obviously, and this is related to the article that I talked about some time ago. That I saw, not article, the response on Stack Overflow about the perception of the threads in relationship to each other. So each thread is like its own timeline. This response here. So I think that's when you have a but I think it's always going to be multi-threaded, whether you have code that uses multiple threads or not, because on the actual hardware, it's going to try to use multiple threads to do more work, obviously, because it's trying to optimize the amount of instructions per clock cycle, and it's going to do. I think in most situations, it's going to do a bunch of context switching, which is basically means that it's going to do some work on some processor, and then it's going to switch to another one. While that other one's not completing, it switches to the other one very fast to give the illusion that's doing the things at the same time. So I think it's going to be like most situations is going to be multi-threaded, even if you don't have on the code. And what's going to happen is both on the hardware and on the compiler, you're going to have optimizations to change the order in which variables are assigned and in what the order in which instructions are done, because you're trying to maximize the executions per cycle. I forgot where I was going with this. I was gonna say something, but I forgot. What is the point? Oh yeah, I was talking about the unique variables. So maybe this is related to the unique variables thing. So as far as I understand, the reason why the LLVM creates or tries to achieve a state where each assignment of a variable creates another variable, so that you have this part I don't remember very well. Was on a course that I actually I'm gonna see if I can find. I think it's Carnegie Advanced Compilers. Extremely good course. I'm probably gonna do that course again actually. It's very good. It's probably I wish they had more courses on this. But the thing is I don't remember very well how I got there. It's Carnegie Mellon Advanced Compilers. Trying to find the course. Like I wish I had uh, saved. Maybe I did save on the favorites or bookmarks. I don't remember really well. If I find the name of the guy. on YouTube, and then I search for that because I know there's a playlist on YouTube, but it's not the actual course. The actual course is on the site. It's on the Carnegie site, but let me use Google or something else. It's not compiler design. Maybe this one is good as well. It was another university as well. Fuck, I'm not gonna be able to find. So maybe another time. Probably gonna search this off stream as well. See if I can figure out. But basically, he says on the course, and I think I agree. I'm pretty sure that it is the way that it works. Is the thing is, I don't remember the nuances of the optimizations, but you basically create a table where you have a unique assignment for each variable, and this allows you to optimize a bunch of stuff because of the reordering of instructions and stuff like that. So it might be related there, the variable on the assembly that they generate there, because it might be a unique assignment to optimize something. Yeah, Cornell. It's not Carnegie, it's Cornell. CS6 compiler. I think I'm gonna find now, because I found the playlist. It's confusing the universities, it's Cornell. Yeah, I'm gonna watch this again, obviously. Because it's probably one of the best courses that I found about compilers. So one of these lecture series, he talks about this optimization that LLVM does. You just basically find a unique assignment. You find all the, so let's say you have A equals 5, and then somewhere along the code you have another assignment to A. Instead of reassigning the value to A, you create another variable, and then you make that variable equal to the value of A, or to whatever value A is going to be updated to. And that way you have unique variables pointing to the same data in memory. So I think it's probably something similar to this that is happening here. But maybe not. But what I think is happening here is just so we're going to start the value on the ECX, and then it's using this, what it looks like it is dereferencing EBP, and then moving 5 there. So maybe maybe this -4 is the offset on EBP. That's probably what's going on. So I think that is EBP -4, and then it moves 5 to there. And minus on the stack is increasing the value, let's say, because the stack grows to lower the addresses. Yeah, it's putting the 5 on EBP, I think, and then it's moving that to ESP, and it pops EBP returns 0. Yeah, because the function doesn't do anything. So I think epilogue is after, is here. So this is basically cleaning up. Actually, I think this part's here. Just cleaning up. I think this is putting the so maybe the 5 is not being put on the EBP. I'm not sure. I don't understand what this is here. Offset from EBP, base pointer. Meeting the variable is located 4 bytes below EBP. Yeah, that's what I said there. But I think it doesn't change EBP, it just moves the value on top of EBP. And then on the other instruction, it's just gonna clean up the stack. So that's why it moves, I think EBP to ESP or something. Yeah, EBP to ESP. So initially it moves ESP to EBP, then it moves EBP to ESP. So it's changing the value. It's changing this the top of the stack to the bottom again, and then it pops EBP, which probably is going to. I'm not really sure if it puts on the return, but it probably. I think on the it's gonna put the pointer on the return address probably. I'm not really sure about this. I think for these kinds of things, it's probably better to use x64 DBG. But the issue with x64 is that there's a lot more stuff, and it's kind of hard to know if you're seeing the code for the actual stuff that you wrote, or some other code of loading libraries and making the process and stuff like that. Because in the beginning, like regardless of how complex your code is, so you can have nothing, like no functions in any libraries on the file, and you only have a main file. There's gonna be a bunch of extra stuff before your code runs, because the operational system is gonna run the code. So the code you write is an interface. So you have the code you write, you have the operational system, and you have the hardware. The operational system is the thing that is gonna create the it doesn't matter which code you write, it has to go through the operational system. Because the operational system is the thing that is gonna set up the process on the kernel, unless you write the kernel yourself, obviously, and you write the operational system yourself. But I think on normal situations, what's gonna happen is that you're gonna write the code in the file, then the operational system is gonna have the logic. It's basically what the operational system is. It's just an abstraction built on top of the hardware to manage the different processes on the actual hardware. So a process is just a pipeline of execution of instructions, and that's basically the core, I think. Yeah, the core is the process. So I think most CPUs nowadays are going to have multiple different cores. So it allows multiple different processes, and everything else beyond that line is going to be an abstraction built on top of that to make the illusion that it's running more processes, but it's just doing context switching. But the process is just going to be the pipeline of the transistors that are going to have the logic gates that are going to create the cycle of fetch the instruction, decode using the decoder probably, which is going to be the instruction set architecture designed on the hardware. Then execute the instruction, and then it's either going to be branch or something with the memory. Yeah, with the memory. So it's basically the computation. All the computation is just changing the memory on the hardware, and then based on the changing memory and the data is going to change the state you see on the screen. And the thing that is going to manage the processes and the hardware is going to be the operational system. So before the process executes, it's going to load the libraries that the operational system is going to use. It's going to create the process environment block and the thread environment block, and the information of the process and it's gonna set the values of the virtual page for the process, and it's gonna use that to translate to do the bridge between what's going on in the memory of the process and what's going on the actual physical memory by using the control register tree to set the flags that are gonna create the pathway from the memory on the process to the physical memory. So I think it's more interesting to put this, or maybe just call the function here. I put 10 and 17, and then compile this again. Then use x64 dbg. I want to see the arguments, what happens on the arguments. Mainly, and also see how does the if-else statements work. I think maybe the if-else is probably better to do before, but I'm gonna have to ask for more examples. Probably the if-else is better to do before this. Now this one seems pretty simple, so let me go back here. But I'm curious now to see what it's gonna look like on the actual executable. So it looks like it compiled. So I'm gonna open x64 dbg and I'm going to go over the simple one there. But probably gonna do if else. Gonna do branch conditions first. Is yeah, the first Anki cards that I think are better to create are the if else because it is confusing on some situations because it's gonna do the branching indirectly and it's kind of hard to think about it if you're coming from a higher level programming language. Because the way that you usually think on the higher level, you just see like all the abstractions that it has embedded into it, and then like you don't see it in a linear way, in the way that you see in assembly usually. Like it's much easier to visualize what is going on. And in assembly, a lot of the times, what's gonna happen is that it's gonna do the comparison indirectly, and it's gonna get confusing because all the differences in the sign of the variable that you're comparing, and basically the overall structure, because it's gonna change the way that you're gonna have to manipulate the variables on the register. So I think yeah, this is something that you don't have to think about anytime basically when you're coding on higher level languages, because you're never translating yourself the actual values on the registers. So this is the stuff that gets annoying. So for example, you have a negative value, and then you can do shift. There's different types of shift. One is gonna allow you to carry or to maintain the sign of the variable by not changing the sign flag, which is an arithmetic shift. And you have the other shift, which is logical shift, which is just doesn't care about the sign bit, which is the last bit on the register. So these kinds of things make, and coupled with the fact that after that you're gonna have an instruction that is gonna take those nuances into consideration to set the flags, and then it's gonna do the jump based on the flags and not on the operation. Becomes very confusing to understand how it works. Now, this is the problem here, is that like starts here. I'm not really sure if this is the code that I have there. So I'm pretty sure on the options last time I removed everything because I thought actually I didn't remove these ones, so maybe it was because of this. Yeah, I think that this is the code related to threads because of the name here. So I'm gonna save this and I'm gonna open again. Sure. But at some points, I do want to go over all the code as well on the setup of the process because it's very interesting to know. But I'm not really sure if this is the most effective way to learn is by going over. So if you don't put anything, then it just stop the execution. Yeah, so I have to put a breakpoint. So I'm gonna put on the options entry breakpoint. It's probably the one that stops in the beginning of the code. It doesn't look like it is. So I'm gonna see if ChatGPT or Perplexity is gonna be able to give me an answer. See if I press F11. Or maybe it is because this, yeah. So I think it is because of the main name here. I think it's probably calling main. So RSP, I'm pretty sure. So let's see. Yeah, RSP is the value on green. It's basically the top of the stack right now. Top of the stack, and it's gonna put RCX on below the stack. So +8 should be this value here. So it's gonna put RCX, which has the header. No, it has another value there. This value, I'm not really sure what it is. And then it's gonna align this stack. Also, I accidentally put uh, twice there. So it puts it has put this value here, which is the RCX. So this is first instructions here. Put the value here, and then it's subtracted for the pad alignment, probably for the shadow store. So 28 bytes for the shadow store. And I think it's because it puts the value there, but it's actually not really sure. So the question is, why is it doing 28? But I guess it's because of the, yeah, but like it's not gonna be a multiple. It's obviously like there's 4 left to be multiple. So it seems something happened before. It doesn't matter that much. I'm just gonna press F7 to step into. So let me see. Oh, I'm pretty sure. Oh, so maybe this is the header. Hmm. Yeah, because I'm pretty sure that I opened the stack frame. I opened the executable related to this file here, but on this one I'm including the examples H here that I thought I might use. So maybe I should comment that out, compile again, and then try again. But it's probably gonna call after this. Actually, maybe probably when you include is it runs the example main. No, but actually it doesn't make sense because on the way that I have the CMake there, I'm not putting the. I'm just putting this C++ file, and I'm not putting the. So it should be running only the header and not the function for the examples here. Security cookie. Oh, no, it's a stack frame examples. So this is probably the main on the stack frame examples. So subtract 68 from RSP for the alignment. So this is after it already puts the 28 on the shadow star here. We created the shadow star before I called the function. And the other one is the return of the other function probably, which was already there. Oh, yeah, it was here, I think, at the beginning because of the thing there. So I think the other function created these values here, and then created another shadow star probably. So it's here now, and it's gonna add 68 for the values. So it moves 1 to ECX. Maybe this is related to the arguments. This here doesn't have any, so maybe it's argc. One to ECX. And then it is gonna call the other function, I think. So these conditions are here. These conditions are probably gonna do. The thing is, I'm probably gonna have to do manually because I think on the book, maybe I'll go back to the book and try to see it again if I have. This is also very useful. Another book that I was reading about cache coherence. But I think that, so this is the register. So this is the structure of the register that is responsible for mapping the virtual pages or virtual addresses through virtual pages. Page directory, index, directory pointer, index, directory, and table. And then the offsets. So the relative addresses from the table are done with the offsets, and then the index of the page is done through this one. So each page is going to be 4096, I think, megabytes, and then from that you have the offsets, I think. But I'm pretty sure I didn't. If the book has this table here for moves, I didn't get. So I'm gonna go back and see. Oh, actually, it has here. So move if result was 0. I think that's the one there. Oh, this is conditional move, but it's probably the same thing. What is the difference? Here is move 0. X. I think X should be for extended. So I think it is gonna. So it is, yeah. No, but it should be very similar because I think that what this does is that it moves AL to EAX if the value is 0. It's kind of confusing because I think AL should be the first byte of. It's either the first or the first 2 bytes of RAX. So we have RAX, then EAX is going to be first 32 bytes of RAX. RAX is 64 bytes. And the other ones I think I don't remember really well, but I think AL is the lowest byte of the EAX. I'm gonna ask ChatGPT. See moves here. Compiler generates this code to handle local variables on the stack. In this case, is a local variable think simple function. Get relative to base pointer. The use of EBP allows the compiler to easily manage local variables and function arguments without worrying about changes to ESP during the function execution. Yeah, whatever. When simple function is entered in the stack frame, setup might look like this. So the return address is below the base by 4, just um, half of a row should be. Save DBP, and local variable is on top of the base. So I think that this is probably in the space of in the shadow star space, because I think usually the top of the stack is gonna subtract from the top of the stack to put the values, or yeah, subtract to put on top of them. No, but the stack at that point should be above the ABP, so maybe not. Move if 0 extends. Moves a value from a source operand to a destination register, and 0 extends the source value to fill the destination register. So it's pretty much zeroing. Yeah, so I think that the move Z doesn't check, just moves, and the other one checks to see if it's 0, and then it moves if it's 0. So I think so the question is, why is using this instruction to 0 the register instead of using XOR? Because the most common that I've seen is use XOR operation on the register with itself is going to 0 out the register. Because obviously all the values are going to be the same, so on XOR they are going to be 0. When they're both 0, it becomes 0, or when they're both 1, it becomes 0 as well. So I think what this is doing is just zeroing out the EAX. I think, yeah, no, but it would be the same thing, I think. So I'm not really sure why it doesn't use XOR. So I'm gonna ask this as well. Maybe it's because of the sign or something, but should be the same, I think. Yeah, so the C moves if the value is set to 0. So if the 0 flag is set, and the move just extends with 0 the value. AR refers to the lower bits, 8 bits. And the lower bits would be the first bytes. Yeah, so it is the first bytes. The instruction moves the value 0, extends it to AX. This means the upper 24 bits of AX are cleared set to 0. But the higher 32 bits of RX, yeah. So this was what I was thinking about. that the reason we choose this one instead of the XOR is because this one is only gonna clear the first 32 bits and not the entire thing. But the thing that I wasn't sure is that when you use XOR with AX, you're using basically the same thing. You're just clearing out the first 32 bits. Fully clears AX. This is because when you run it through a 32-bit register like AX, automatically zero out the upper 32 bits of. Oh, so this is good to know. So it doesn't matter that you're only XORing the first 32 bits, because it's gonna clear everything. Obviously, I'm not 100% sure if this is true or not, because it could be hallucinating, but I think it's likely to be true. But obviously, we're gonna see later. Yeah, whatever. So this is interesting as well, because I remember seeing something like this, but I think I saw this more for virtual functions on C++. So I think whenever I have virtual functions on a class, what the compiler is going to do is going to create a table of these virtual functions in memory, because obviously it's more efficient or effective to do this way, because then you create the function only once because it's virtual, and then every time that you have another class that inherits from the other class, you're just going to get the function from the same place in memory. And I think that's called virtual function table or something like this. So I think it's something similar that is happening here. It seems that it's putting all these addresses for the functions on uh, this displays in memory, and then it's going over here before it calls the function. But this is the first time that I've seen this. I haven't seen this on the other executable, so it's kind of interesting. Not really sure how should I ask. Just gonna ask GPT. Oh, this is the annoying thing. Well, there's. Oh, I swear. I just press of 7 choose step intro. So it's gonna put the ECX value on 8. ECX should be 1. So it's the one that you put there on the other function before. So it puts 1 here, then creates the shadow space here. And it's gonna compare to see if the plus 30 is 0 on this stack. So it should be from the current top. So if it's 28 there, it's gonna be here. 28 should be 4 or 3 values and then half, 3.5 rows. from the place that it was before. Sure. So it's gonna be, I think it counts one from here, so 1, 2, 3, and then it should be somewhere along here, I think. So checking the first 6 bytes of this address here, I think, just see if it's 0. So it probably, so it's gonna be true, I think. It's gonna set the 0 flag to 1, I think. So it didn't set. Hmm. That's weird. So I'm gonna, maybe I haven't the picture. I don't have, I think that's, I'm not really sure if the book had compares, but I might go back to see. But it's probably easier to just find online. To see how the compare works. So I'm gonna ask ChatGPT again. I guess that is gonna subtract one value from the other. But if you're subtracting 0 from 0, then obviously it should be 0, which should means that it sets the 0 flag to 1. So I'm not really sure what is going on there. Unless I'm looking at the value the wrong way, which could be the case. But I was looking, so I think that the stack pointer didn't move since last instruction. So it's gonna be this address here. So plus 30 should be, each row is represented in decimals. So each row is 16 decimals, 16 hexadecimals, which is the equivalent of 64 bits, which is the equivalent of 8 bytes. So each row is 8 bytes, and the value here, even though it's written in decimal, is going to be in bytes. So it's 30 bytes. So that's 3 rows and 6 bytes. So if it is here, it should be like 1, 2, 3, and then this value here. That's what I'm thinking right now. So it should be the first 6 bytes of this row here. So 6 bytes. So 6 times 8 is 48. Then divided by 16. I'm not sure if it's divided by 16 times 48. So divided is divided by 4 times 3 is going to be the first 12 squares. Obviously, it's going to be 0, everything. So jump short if not equal, not 0. So it's going to jump here because the 0 flag is not set, but I'm going to copy that to see. I'm going to ask this one first. So it's basically saying that the compiler puts there because of the libraries, so to make it easier to find the functions. In executables and DLLs, dynamic link libraries, the compiler or linker might generate this jump table to ensure that all calls to a function go through a central point. This allows for lazy binding, where the actual function address may not be known until runtime, especially in dynamic linked libraries. Function replacements. If a function's address changes or needs to be patched, e.g. due to ASLR. So this is just randomization of addresses on the process in order to make it harder to exploit. Or hot patching, it can be updated in one place, you jump stub rather than at every call site. Jump table, the compiler linker can reduce the need for direct calls to the actual function locations. It allows more flexibility managing function addresses, especially for functions like initialization routines. That's why I ask if it is the compiler that is generating this code or the process, the operating system code that is going to create this structure. Compiler and linker and the operating system. At this part is still like I have to clarify this. Like it's kind of hard to clarify though, because like if the it's like making very clear the line of separation of concerns between like the code that you run and the operating system. So what's obvious to me is that the operating system is going to have the code that structures the process and structures the virtual addresses. And then it creates a connection between the virtual addresses and the physical addresses. But what is not very clear is from the compiler's point of view, how does it know the addresses in which it's going to put everything? So I think either there is a standard address that the virtual addresses of the process are going to have always, and then the compiler uses that, or the compiler uses an abstraction, and then the operating system is another standard that the operating system has, that based on the compiler is going to translate that standard addresses that compiler is going to produce to create the actual virtual addresses on the process. So I'm gonna, before I ask this here, I'm gonna ask this. So I'll be right back. The compiler itself does not know the final address. Final virtual addresses generates code with relative addresses or placeholders, and the linker operating system are responsible for finalizing the actual addresses. So this is something I'm curious about as well. So the compiler uses relative addresses, and the linker operation system are going to translate that. Blah blah blah. Whatever. Yeah, so it does one minus the other. So if the result is zero, it should set the zero for lecture one. So I don't understand why it's not setting. Unless it's using the address, but that doesn't make sense. I think it compares the value on the relative address of RSP30. I wonder if there is a way to. So I'm gonna try to copy expression. Copy RSP. Or maybe I can just put the expression like this. RSP30. Oh, so it's here. Oh, hmm. Interesting. So why is the calculation? Oh, I think it's because I'm doing, yeah, it's not decimal, it's hex. So that's why I'm confusing. I just remember this. So I remember because the way that I figured this out is the last time that I did this, I can press spacebar to type instructions, and then I put the instruction decimal here, but then it translated into hexadecimal. So I think it's always hexadecimal. So it's not gonna be 30, it's gonna be 48, I think. Because hexadecimal is like the same as binary, but you translate in a different way. So in binary, each square is going to be the 2 to the power of the value of the square, and the index of the square, which is basically the same index that array uses. So it starts with the 0 and increase by 1. So the first square would be 2 to the power of 0, and in hexadecimal is going to be 16 to the power of 0. Then the second square is going to be 16 to the power of 1, multiply by whatever decimal we have there. So it's going to be 16 times 3, which is 48. So it's going to be 48 bytes, not 30. That makes a lot more sense. So 48 bytes divided by 8 is going to be 6 rows. And I think it's from this. So 1, 2, 3, 4, 5, 6. Yeah. So it's checking to see if the value of ECX that it pushed before is 0 or not. And because it's 1, then it's not equal, so it's going to jump here, I think. But I wonder how this is related to the code here because it's not the same. So maybe it's from some other stuff. I guess. Yeah, so the jump is just going to skip the instruction here. So it's not 60 bytes here. It's going to be 6 times 16 is 96. So 96 divided by 8, how much? It's going to be 12. So 12 rows. Security. So I think this is code related to something else. So I'm probably gonna have to. I think I'm gonna stop streaming now, and I'm gonna have to search for this. Because the thing is, I found it. The thing is, I'm not really sure. Like I watched some videos on 64dbg, but I don't remember if any video talked about this. I think they did, and I probably forgot. And on the documentation, I read the documentation as well, but I don't remember really well. So I'm probably gonna have to go back to the videos that I watched to see how can I make sure that I'm because this doesn't look that it is on the main. I think that this is stuff before the main still because this security cookie here. So I think these functions here are not the function that I have there. What I want is to stop on the main function that I have on the actual code so that I can compare with the stuff that I put there. And I'm definitely gonna use the 3 different methods because I think it makes sense. So this is the pattern that I'm going to, like what I'm gonna do is just ask more examples. So I already have this stack frame, I think, so I can, but I'm gonna look for more videos about this. Because the problem with the examples on the stack frame, I guess I'm gonna be able to see after. But ideally, I would have examples that highlight the convention of the procedure called linkage. Because this is the stuff that I'm trying to clarify, is this conventions of the registers here. The main doubt that I have right now is what happens if you have a situation where the registers already have values and they don't want to discard the values previously. So where do you save that? I assume that you're gonna allocate some different place on the stack, maybe the shadow star, like the common says there. Or like it doesn't make sense to allocate in memory, I think, because in memory is lower. So the hierarchy is going to be register are the fastest way to access data. Then it's going to be the caches, and then it's going to be RAM, and it creates a funnel because the space-time relationship. So I think the compiler is always going to try to optimize to use registers instead of memories. So it's probably going to use the stack to save these temporary values of registers, and that's probably why you have this convention here. So depending on the compiler, these are the registers that the caller is going to save. Is going to use to save values, and the callee is going to use these other registers to save values as well. And it looks like these 4 here are going to be for the parameters. Shadow storage is used if a function needs to save its register parameters in memory. But the thing is that I'm not really sure what this means on a higher level language. So is this saying that whenever I have a function that has parameters and the parameters are going to change inside of the function? Like let's say you pass a parameter with a pointer, then you're going to use the shadow star to store the parameters. I think that's probably the situation. So obviously I can test this by putting examples of functions that accept a pointer to a structure or something like this. And that's probably what I'm gonna do. So create examples here, then compile them on the get executable, put them on the Godbolt or Godbolt compiler. Then look at them on the Godbolt, look at them on the assembly file that gets generated from this. These assembly files here. and then look at them on the x64 DBG as well. Then as I go through the cycle, I create Anki cards to retain the information based on the patterns that I think are like most fundamental. So the 80-20 rule basically, and that are harder to remember. It's probably gonna be the nuances on the flags, the move instructions, and the control flow registers or the build field registers that are gonna encode the flow of data from the process to the physical address. It's gonna go fast here, so what happens also, and maybe it was. So I think it had to be related because it stopped executing, so it was one of the final things there. I guess one thing that I can do to make it easier, just realize this, I can create a string and then I can use the. But I think I'm gonna do this off string. So what I'm gonna do is just create an example here with a string, and I think I can do this. Then I can look for I can search for the pattern on the. I have to see how to search for the. I think if you search for expression, it's probably gonna be like go to the expression. Or actually, there is other ways there, but I'm gonna search how to search the string. It's probably the easiest way because then it's gonna have this pattern on the code, and I'm gonna be able to see on the instructions where does it start the main. But I'm not really sure if that's gonna allow me to have an idea of how to put the breakpoints there. But yeah, I'm gonna stop here. So next time I'm gonna continue to do this and build the Anki cards and study assembly. So see you next time.